All right, good evening, everyone. Welcome to the September meeting of the RASC, the Ottawa Centre. Thanks for coming. It seems like we got a pretty good crowd for a reasonably nice evening, even though it's a bit muggy. We got quite a bit on the agenda tonight. After Gary does his Ottawa Skies segment, I'm really delighted to have Carmen Rush speak something she used to do a while ago, which I really missed. And I'm delighted she's back to give it what I hope will be the first in a series, again, of historical figures in astronomy, people who have helped advance astronomy. So for those of you who remember her presentation, she's very captivating. We've got, after that, Dave Chisholm's going to talk about the North Frontenac observing site. There's been some interesting things that have happened about it. It's a new site, but it's also some interesting things that have happened. Dave will talk about that. And we'll have a break and during our break, we'll have people pick up their tickets for the door prizes if you haven't already. After that, we have Chuck O'Dale, who's going to talk about impact craters as he frequently does, and how fortunate for us. Eric's going to talk about a outreach that he did at a school with an extra twist, as you'll see. And we had we've been fortunate to have two star parties this year, one in July and one in August. So we're going to also talk about that star party as well, and some upcoming ones. Ton of announcements, outreach announcements, and there's a large segment of observer images as well. So is there anyone here who is the first time they're here tonight? Maybe you could raise your hand. All right, there's a couple of hands. Welcome. It's a delight to have you. I hope you enjoy tonight. If you get a chance, come up and maybe say hi to myself or to Gary Boyle, who's in the corner there. We'd like to hear what interests you, and hopefully we can design a program here, both through this meeting and through the various aspects of our club that interests you and keeps you here. So. Is Denise, Gregory, Toby? Are you one of the new members here tonight? If you are, raise your hand again, please. Okay, I don't see you, but this always happens if somebody comes up to me and says, "I'm Denise," later on. But we'll hope to see you. Okay. So Gary, over to you with the September Skies segment.
Thank you, Mike, and good evening, everyone. Welcome to the Ottawa Centre for first-time visitors. And for people that survived the deluge today, downtown was just like a monsoon. Couldn't believe it. So welcome to Ottawa Skies for September of 2014. And of course, those watching on the internet around the world, which we do stream live on the internet. So the first slide, of course, I change slides rather than Orion all the time, but it's be changed pretty soon. Slide that I've taken, pretty well the summer triangle, and that's pretty well what you can see after sunset as the summer Milky Way, the Milky Way is starting to recede, and here we have Scorpius with the reddish star Antares. Okay, next slide, please. Well, those that have been following the sky have noticed that, and here's Antares again along with Scorpius, that we have Saturn and Mars that were very close together, but now Mars is starting to really move along on its orbit around the Sun, because it is closer to the Sun than Saturn really is. But I'm sure in the gallery we'll see just a few dozen conjunctions of what we had with the Moon. Okay, next slide, please. And in the morning sky, you probably notice bright Jupiter, but up about 2 hours before sunrise in the eastern sky. Planet Jupiter, the largest planet of our solar system, and was pretty close to the Beehive cluster, M44, a beautiful, loosely open cluster of stars. But now, of course, and Jupiter is moving off to the east along the ecliptic. Next slide, please. And as Jupiter is rising early and earlier each night, those with telescopes who has never seen Jupiter in a telescope? Ah, good. So it means the other ones have. Good. Well, those that have not seen it, hopefully you can come to one of our star parties. It won't be up really that early because we don't stay out that late, only until 1 a.m. But if you do have a chance to get to someone that has a telescope, Jupiter is a phenomenal planet to look at. It has 4 grand moons, the Galilean moons, Io, Europa, Ganymede, and Callisto. And in the Observer's Handbook, which is part of your membership of the RASC, on page 234 to 236, gives the actual timings when the moons will be coming close or actually transits such as Io. And here's the shadow of Io on Jupiter itself. Okay, next slide, please. The one object to look at this month is NGC 6791. It's only 13,000 light years away from Earth, still in our own galaxy. But its age, it's about 2/3 the age of the entire universe, our known universe, about 8 billion years old. You will need a telescope to see it. It's very, very sparse. And astronomers are still not sure if it's a very loose globular cluster or a very compact and dense open cluster. But still, it's a very, very old one to look at. Next slide, please. And here's the finder chart. Right here. No. That's the right one. Yeah, it's right there. So here we have Lyra the Harp, along with Vega, 25 light years away, and it's just over here. So pretty well any star chart will allow you to look at this open cluster / globular cluster. And next slide. Comet Jacques, again, probably a few dozen images of Comet Jacques again this month, right, Mike?
Oh, yes.
Okay, for sure. Comet Jacques is the comet at this time of its path. It's not bright. Binoculars, pretty well a telescope, but now it's actually going right through the Milky Way. And in fact, even Glenn LeDrew last month attested when I showed the previous chart of Comet Jacques, when it was going through Perseus and Cassiopeia, it was going actually through the Milky Way. So on the 4th, which was, last night, it was next to Deneb, bright star of Cygnus the Swan. And on the 14th, 10 days later, will be right next to Albireo, beautiful double star. Next slide, please. Well, kind of the seasons are changing as always, because our stars move about 4 minutes, or really our position moves 4 minutes every night. The Earth actually rotates in 23 hours, 56 minutes, and 4 seconds. So with that 4 minutes, we get new stars rising and old ones setting, and then the change of seasons, the newer constellations rise. And here we are in September. You can see that it's equinox, meaning the sun equal. The solstice means sun stands still. So either in wintertime, the sun's very low, or in summertime, very high in the sky. But for fall and springtime, equinox, 12 hours of each. And after the 23rd, now the nights will start to supersede the daytime hours. I have 2 dates down here because here we have universal time at 2 hours and 29 minutes in the morning UT, and that's Greenwich Mean Time, the old Greenwich Mean Time in England. But switching 4 hours to Ottawa is actually the night of the 22nd at 10:29. Okay, so for us, it's September 22nd. Next slide, please. And the great thing too about having during the vernal equinoxes is that we have a chance to see the zodiacal lights. Our planets are pretty well like ping pong balls on a table when the planets were formed. And between the planets, right after the sun and beyond, there's a pretty well fine layer of dust on that plane. Just like if you haven't dusted for about 2-3 weeks, you'll notice dust on a table or on a shelf. Well, it's this time of year when the sun, we're lined up with these dust particles, and before sunrise in the fall and before sunset in the springtime, you will see this column of light, very, very high in the sky, about 45 degrees high. But you do need dark country skies. If you're in the city, forget, you will not see it. The moon's out, you will not see it. The best way is by photography, but I have seen it naked eye a couple of times. So that's one thing to look at. And that's starting on September 20th when the moon is out of the sky pretty well for a 2-week period until the moon starts to interfere. Next slide. And just before we go to this, the people probably heard on the news asteroid 2014 RC coming closer to the Earth on Sunday. It will come closer to the Earth, but only within 40,000 kilometers, 25,000 miles. And at the time that's theoretically close to our planet, it's at 2:18 Eastern Daylight Time, which means it'll be on the other side of the Earth. But the Sleuth Observatory will be broadcasting a live feed. It's about 12th magnitude, 13th magnitude. It's not very large. It's only about 60 feet long. Pretty well the size of the meteor that struck over Russia about a year and a half ago, and imploded and exploded, sort of thing. But yeah, the only way to see it is unless you go to New Zealand, so you don't have much time. So here we have the lunar effects with the full moon. We have the harvest moon coming up, and the last of the supermoons. Finally, getting rid of the supermoons. And supermoon really is just the distance closest to the Earth and being full phase. Last month was the best of the three. And last quarter, full, and first quarter moon here on the 1st. Okay, next slide. And just to sum up, my monthly article that appears on the national site has a lot of these charts which I showed you tonight, especially with the comet, if you want to find Comet Jacques. So it's in the article. And you can easily get on that from the Ottawa website, ottawa.rasc.ca. My website, wondersofastronomy.com, or you can also follow me at astroeducator on Twitter. Next slide. And that's it for this month. Have a good September.
So Gary's a familiar voice. You might hear him on the radio from time to time. I know that he does some. He fortunately promotes our radio announcement or our star parties on the radio. So you might hear him from time to time. If you do, send me a note because I always like to follow up and see how that's going. Radio promotions definitely help. Carmen, you're next up with our historical figures in astronomy. Thanks.
Well, hello, everybody. It's been quite a while. I know that I have been giving a talk, and I think it's probably 10 years, I dare say, but I am now retired from teaching. In fact, it's the first time, the day after Labor Day, that I had not gone to school since 1963. Because I started as a child, obviously, and I never left. I just came back and worked there. It was kind of surreal. So my talk tonight is about a lesser-known astronomer. His name is Christian Olaf Birkeland. He was a Norwegian scientist who was the first person to correctly explain the physics behind the aurora borealis. He was born on December 13th, 1867 in Christiania. It was known then, but it's now called Oslo, capital of Norway. And his parents were in the import-export business and ran a small store where they sold their goods. And Birkeland had an older brother who was very successful. He became a medical doctor, but Birkeland himself was very talented in math and physics. Next slide. And already by age 18, he had published his first scientific paper. And by the time he was 20, he was solving problems that defeated the most experienced of researchers. By the time he was 28, he was the first to use Maxwell's equations to study the mathematics of X-rays. And so at 31, not surprisingly, he was elected physics professor at the University of Christiania, and he was the youngest in the Faculty of Science and Math. And it was from there that he surrounded himself with the greatest minds of the day. He traveled all over Europe to meet with them and kept up with their discoveries. And these are very famous people. It was a very prolific time in science at the turn of at the end of the 1800s. People like James Maxwell, the father of electromagnetic equations, Marie Curie, who studied radioactivity, Max Planck, Ernest Rutherford, Victor Hess, Robert Millikan, Niels Bohr, Heinrich Hertz, Louis Pasteur, Willem Röntgen, he's the guy with the X-rays, Albert Einstein even, many more. But in spite of everything, he was still very fascinated by Maxwell's equations, and he believed that he could use modern physics to explain the aurora borealis. Next slide. So first of all, I'm going to give you a little crash course on what the aurora borealis is. It's more commonly in this side, in Canada, known as the Northern Lights. Aurora borealis are Latin words meaning dawn of the north. These shifting magical lights in the sky are caused by collisions between gaseous particles in the Earth's atmosphere with charged particles released from the sun's atmosphere. And this stream of electrons and protons is thrown from the sun's atmosphere as it rotates, and it escapes through holes in the magnetic field of the sun. So this solar wind, so-called, that's created of charged particles stream through the solar system, and some are caught by the magnetic field of the Earth. And on the Earth, at the poles, the field is weaker, so some of the particles enter the Earth's atmosphere and collide with gas particles. The green light we see is as the result of collisions with oxygen. Next slide. The blue is from nitrogen. And next slide. And the red is from very high altitude oxygen. The lights, in fact, never touch the ground. They're anywhere from 80 to 600 kilometers above the Earth, and they form an oval around the pole. Auroral activity is cyclic with an 11-year cycle and increases with solar activity. Aboriginal people believed that these lights were the spirits of their people, but in Northern Europe, even in 1900, in the era of Berkeland, their presence was seen as a sign of impending death. In Iceland, for example, they were believed to be spirits of the unhappy dead, coming to cut off your head if you dared to venture outside. The Vikings believed the lights were spears of female messengers of the god Odin, coming to mark those who would die in battle. The Laplanders thought that they were messengers of God, and the lights would attack those who looked at them. In fact, they were so scared they would not even cut their hair on that day. That was another superstition. In Norway, they were called bloodlights, and they were seen as the souls of dead warriors coming to warn of war and death. And it certainly didn't help matters much for the superstition of the whole thing that when the assassination of the Empress of Austria occurred in 1898, it was preceded by an especially intense red aurora across the entire sky. Next slide. Berkeland was actually intrigued by all of these superstitions, and he was determined to prove them wrong with science. So he wanted to mount an expedition to the far north of Norway to conduct experiments on the aurora, and had no trouble getting a substantial grant from the university and government to do so, because at the time, Norway was in an economic and political union with Sweden, much against their will, because Sweden had defeated Denmark and Norway in a war in 1814. So if Berkeland could make new and important scientific discoveries, it would do a lot for the civic pride of Norway. So in 1899, with 12,000 crowns to spend, just to give you some perspective, his salary was 5,000, but he was able to get this 12,000 grant from the government. Next slide. He had built a small stone observatory, which you see at the top there of that photograph, at the top of a mountain called Halda Mountain. It was right at the very tip of the northern part of Norway. And a smaller hut was built on the neighboring peak called Talvik. We'll just have a look at this first. So next slide. So it's a historic site right now. Today it's a museum. So that's the stone observatory. And next slide. That's the interior. Sorry for the graininess. It's hard to get photographs of that. And next slide. So you can see these observatories right at the top there, and that stone building to the right was built quite a bit later. So he had built a cable car system that was designed to ferry supplies up the mountain, and a telephone cable was strung between the two mountains where the two observations would be conducted. Berkeland's plan was to spend the entire winter there from October to March and to observe and measure the aurora. This was actually much to the dismay of the Lapps who lived at the foot of the mountain. They warned him, next slide, you can see how desolate it is over there. But anyway, the Lapps warned Berkeland not to go there because they said that the winters there were very treacherous, and even the locals there moved off to the coast at that time of the year. However, Berkeland didn't care. He was bent on going there, and he was able to hire a Lapp guide, lucky him, and he took 4 willing students with him in October. Their trek from the mining town of Kafjord, which was right at the tip of Norway, some distance away from there, they embarked with 6 reindeer and sleds. It kind of sounds like Santa Claus with a few reindeer missing, but they embarked on this trip then over snow. And the Lapp guide assured them it would only take 6 hours, so they didn't have to bring many provisions. Well, it ended up taking 24 because a sudden winter snowstorm forced them to set up camp and wait it out. Luckily, all of them did survive, but one student got such severe frostbite on his hands that in the end he had to return home. Halda Mountain, other than the weather, was actually the perfect choice, though, for an observing site because it's 1,000 meters above sea level. It has no light pollution, no trees, and this would allow them to determine if the aurora originated from the Earth's surface or from the sky. There were many out there that believed that it was fire coming up from the Earth's surface. He had actually state-of-the-art instruments. Next slide. From Britain, France, Germany, and Russia for the time, photographic equipment, an anemometer to measure wind speed, an electrometer to measure any electric current in the atmosphere, alcohol and mercury thermometers, a barometer to measure air pressure, hygrometer to measure humidity, but most importantly, which proved to be, were 3 magnetometers to measure the strength and direction of the magnetic field, and all instruments were attached to the roof. It's really interesting actually reading the history of things, how these instruments were built, because this was well back before the days of computers and such. So I'm just going to describe in more or less how the magnetometer was built. It was German design. It was about the size of a shoebox with a 6-centimeter hole in one end and a quartz thread hung in the box with a tiny magnet on the end that would be able to sense changes in the magnetic field caused by the electric current flowing even 100 kilometers or more above the ground. And then as this magnet would turn, a narrow beam of light from an oil lamp, which was focusing on the small mirror, would then be reflecting off onto a page of, or a long roll of photographic paper. And this photographic paper scrolled forward using a clock mechanism, and it had to be rewound every day. If the magnet moved in any way, these changes in orientation then would be recorded on the paper through that reflected light. Next slide. I should also mention at this point that this mission was a very daring one personally for Birkeland because he didn't have very good health. He was very slight. He never exercised. He was often very depressed. He had erratic eating habits and regularly took a barbiturate called Veronal to help him to sleep. But he was a brilliant and manic researcher, and those pushed him to mount this expedition. He would often lie all alone on the roof of the observatory to visually watch the aurora, and it was his dream to eventually have the observatory manned all year. Well, Birkeland was not disappointed. It was clear almost immediately that the aurora did not touch the Earth's surface from their observations, and that they formed an oval around the pole. And by November 1st, the group was taking 3 measurements a day, and it didn't take them long to notice that the high magnetometer readings brought more intense auroras. And by the end of November, the last sunlight vanished, and they went through the next months in pretty well darkness, with maybe 3 or 4 hours of twilight. And you saw how small that building was. You had 4 people crammed in there for months at an end. Temperatures were terrible. They were minus 30 or worse. And on January 11th, 1900, a bitter winter storm moved in, and it cut them off from civilization for 21 days. They were in complete darkness except for their oil lamps, and the telephone and cable car connections were severed. There was constant howling wind, and an avalanche of snow forced them to stay inside. They couldn't even open the door to get to their larder. So now was the time to make lemonade out of lemons. Birkeland used this downtime to pore over the 250 rolls of magnetometer measurements taken since November 1st to see, in fact, if the data could lead to a theory. So he furiously worked with Maxwell's equations, and he was in the end able to show that it was possible for electric currents to produce measured changes in magnetic field strength. He even went further and surmised that there was a correlation between sunspot activity and magnetic field disturbances and the aurora. He became convinced that the beams of charged particles coming from the sun got stuck in the magnetic field of the Earth, traveled along the field lines, just as I told you earlier, and excited atoms in the atmosphere to produce the colors seen in the sky. Well, 21 days later, the storm passed, and they were able to survey the damage. Their larder was gone, the anemometer was gone, and one of their group was sent down to get more supplies and died in the avalanche. But finally, contact with civilization was eventually made, and finally on March 15th, they left Halda Mountain and returned by steamer to Christiania. Next slide. Birkeland did not get a hero's welcome when he returned. He had overspent his budget 3 times over the original 12,000 crowns. He knew that he would never receive a grant again to do his research. So anyway, in any event, he published a book on his findings in 1901. He wrote it in French, actually, because that was the language of diplomacy of the day, and it was spoken all over Europe like English would be today. The book was very well received all over Europe, and he lectured extensively on his results. Only in Britain, specifically the Royal Society, headed by Lord Kelvin, the father of thermodynamics, said that Birkeland was wrong, and that because space was a vacuum, particles could not travel through it. This was very unfortunate for Birkeland because the Royal Society was a very highly regarded scientific body of the day. From there, his mental health deteriorated. He became very depressed, heavily addicted to alcohol and Veronal, but in spite of all of that, he still pushed ahead, this time planning for an expedition that would cost 38,000 crowns, even having overrun his budget before. Knowing that he would have to raise the money on his own, he threw himself into new inventions that could earn him some money. In fact, over his lifetime, he was to take out 59 patents on everything from margarine, hearing aids, treatment of organic waste, fish drying methods, caviar from cod roe, but most notably a furnace that could manufacture fertilizer, an electromagnetic cannon, and new methods of developing hydroelectricity. Next slide. Such as a plant like that was of the day. Just have to get a swig of water here. He first of all focused on the hydroelectricity. He worked as a consultant for private hydro companies and designed a new on-off switch. Next slide. Can you give me the next slide? Here he is. He's third one in on this seated there. He was one of the consultants there for one of these corporations. So what he did was he came up with a plan to design a new on-off switch for huge currents in power stations. When he had, what he had actually designed was a huge solenoid, which is called a coil of wire, that created a magnet that when current passed through it. And this magnet would reverse polarity when the current was reversed, and that would create the on-off effect. Well, while he was demonstrating his prototype, he created such an electric shock that it threw him to the other end of the room he was in. And all the fuses in the power station blew, and a fire started. Well, most researchers would probably have packed it in at this point. But no, Birkeland saw that as a prime opportunity. He thought, well, this is really a powerful piece of equipment here. So he instead called it the electromagnetic cannon, and he saw it as a potential weapon for warfare. So what he did was he contacted the military, shipping companies in other countries, notably Germany, and in no time he had redeemed himself because all the parties that he contacted were very interested in his research. And when next he asked for funds to mount this Aurora expedition, he at once received 20,000 crowns from the Norwegian government, another 18,000 from private sources, and he borrowed the last 5,000 crowns against his newly formed firearms company, and there he was ready to go forward. Next slide. So this one was a very ambitious project. This expedition was to take 1 full year, and it would involve 4 teams of scientists, and they would go to 4 different locations. Darøyfjord in Iceland, where all those arcs focus there, that's Darøyfjord in Iceland, and Kafjord in Norway, that's right up the north there where he originally set off, and Halde Mountain is just above there. And yes, which button do you press?
Top button.
Brilliant. I like this toy. It beats a piece of chalk. So that's Iceland. So they were at Darøyfjord. And then he sent another crowd up to Kafjord, which is where Halde Mountain would be, just right at the tip there. And another group went to, where am I now? The island, to Axelund on the island Spitsbergen, which was 900 kilometers north of Norway in the Arctic Ocean, right there. And you have to remember now, this is in around 1900. You know, now you can just fly there. In those days, it was like by ship, some of them by train, you know, crazy distances. And the last one was in Matochkin Shar in northern Russia, on an island. And that was called Novaya Zemlya. Birkeland wanted to be adventurous, so he decided to go to Russia. So on July 1st, 1902, he and some students and other researchers left for Russia at the same time the other groups left for their destinations. And this trip was 3,000 kilometers, first by rail and then by ship, to Arkhangelsk, which was a trading station. It was right at the tip around there. And then they had to still go by steamer up to the island. Next slide. So here's one of the most famous pictures of Birkeland. Here he is seated, very dapper. And there is his Russian guide, and then the other gentleman there. And they're all decked out in these reindeer suits, so like of reindeer hide. And he wanted to look very official, so he was just sitting there in a suit and tie. So this picture had just been taken, and just after that, the group got up and they started to walk off, and one of the guys that was with him came across a rabid dog, basically crossed in front of his path, and the dog bit him, but he had so much gear on it didn't really hurt him, and then the dog moved over and bit Birkeland in the leg. So everybody was very concerned, obviously, because it was bleeding profusely, and not only that, the dog was rabid. It was quite obvious. So he could not go further, and he had to go to Moscow for treatments. So luckily he did survive, but basically he was not able to go on that mission. In the meantime, the rest of the members of the Russian expedition left for Matochkin Shar. They had awful weather, temperatures of -42, constant snow, fog, wind. The group who went to Iceland faced equally harsh conditions and returned after 10 months. They gave up. And at Axelun, hurricane winds destroyed the instrument house. And at Kafjord, they were clouded out for most of the time. However, in every case, though, very good measurements of the magnetic field was taken. And at that time also, Birkeland had put out a call to researchers all over the world to measure also at the same time the magnetic field and observe aurora in 23 different locations he was able to get. One of them notably being Toronto, by the way. And they all sent him results that they had taken over this period of time. So with all that data amassed, he was able to publish a 3-volume book. Next slide. That's the cover page of volume 1. Of his findings, this time he published it in English, hoping to win over Britain. And in fact, this really did put Norway on the map for scientific research. In the book, he correctly explained the science behind the aurora. His findings were very well received, but unfortunately not again in Britain. Well, while this year-long research was going on, and Birkeland was forced to convalesce at Christiania for most of it, he decided to continue to work on patents that would bring him the money he wanted for further aurora research. His dream was to use 50,000 crowns to build a permanent laboratory for auroral study. First, he tried building a massive electric cannon that could be used as a torpedo from ships. Unfortunately, the 3,000 amp current he used destroyed the machine. Then he decided to move in a completely different direction, he ended up designing a furnace. Next slide. This is a very famous drawing, a schematic of the furnace that he built that would synthesize fertilizer, and he was very successful at this. He was able to produce sodium nitrate from this concoction of combining, I'm not going to go into the chemistry of it because I'm no chemist, water, and heated it greatly with air, and he was able to get sodium nitrate out of that, among other products. And this invention was so successful, he got 75,000 crowns when he sold the patent. And then he also received 135,000 crowns from Norsk Hydro, that's Norwegian Hydro, when they bought out his shares, and 12,000 crowns per year from the newly formed fertilizer furnace company, so he was an extremely wealthy man. He used a large part of this money, along with a grant from the Norwegian government, to build a permanent observatory at Helge Mountain. Next slide. So that's, when it says 1912 on there, that's the other building that I mentioned earlier. The little observatory is up higher over here. So this is the new building that was built. And someone was supposed to live there then, which someone did. Birkeland then decided to recreate the aurora in the laboratory because he figured he couldn't continually persuade people to go on these crazy expeditions. The word was getting out that he had some pretty wild ideas. So he thought, well, if he can't go to the aurora, then he will bring the aurora to him. Next slide. So he created what he called the Torella. He placed a magnetized metal ball, which he called his Earth, in a large vacuum tube, and that in itself, this vacuum chamber, was a challenge in itself to build. Many, many prototypes before he actually got one that was actually, could create a vacuum. And he bombarded the ball with cathode rays. So these are the cathode rays. He bombarded the cathode rays to represent the charged particles coming from the sun, and lo and behold, the electrons in the cathode ray moved to the poles and created, next slide, and created this effect of an oval of light around it. Just as an aside, if you're wondering, did this guy have any time for a personal life? Well, in 1905, he did marry a longtime friend, but unfortunately, because of his frail mental health and obsession with work, the marriage didn't last. It only lasted 5 years, and that really turned things, in a bad way for him when it did end up in a divorce. From there, he became much more addicted to alcohol and Veronal, and he overworked to the point of exhaustion. Next slide. So he decided he needed to change. He decided to go to Egypt. This wasn't such a crazy idea, actually. Actually, he had always been obsessed by Egypt. If I can just have you go back one slide. That little hat he's wearing, that's an Egyptian hat. I think it's called a fez or something. Anyway, he would often wear that hat for kind of good luck. Whenever he would want to work on building a patent or a machine or anything, or even when he'd work in the laboratory, he was obsessed with Egyptology. So in 1913, he left for Egypt. Next slide. He'd always been fascinated by Egypt and decided to make a complete change by moving there to study the zodiacal light. Next slide. And as Gary mentioned earlier, this is an example of the zodiacal light, which is, as Gary said, it's the light we see extending up from the horizon, either shortly after sunset in late winter or early spring, or shortly before dawn in late summer or early autumn, and it occurs when sunlight reflects off dust grains that lie in the same plane that the planets move in our solar system. Can you just go back one slide to the map? Yeah. So he first went to Khartoum, somewhere down. Further off this, I guess. Yeah. Okay, my apologies. My challenge is trying to get that off a book in the end. Okay, so it's somewhere down there. Oh, did it again. So first of all, he went to Khartoum and started taking measurements there and doing observations with very elaborate photography equipment. And he was so influential there, they were so impressed with this guy, coming out of, Norway of all things to Egypt, that he was able to convince the city to turn off the street lamps every morning at 3 a.m. so that he could photograph the sky. Too bad we don't have that influence. And from there, he moved to an observatory in Helwan, which is up here. And it was manned by British scientists, and he did a lot of work with them. Next slide. And next slide. And there he is in another Egyptian dress, dressed as the prophet. Well, unfortunately, World War I broke out in 1914, and most researchers and assistants returned home, and Birkeland found himself alone and isolated, but relatively safe because Egypt was a British protectorate. But by 1917, he had had enough and decided to return to Norway, first going to Japan to meet colleagues at the University of Tokyo. Little slip, yeah. University of Tokyo. Sadly, though, he overdosed on Veronal, and he died alone in a hotel room on June 15th, 1917. So after Birkeland's death, next slide, his theories were disputed for some 50 years. Nobody still really believed that his results were true. It took until 1962, with the instruments on NASA's Mariner 2 spacecraft, the spacecraft there, going en route to Venus. There, the spacecraft recorded the presence of electrified gas traveling at high speeds through the solar system. And in 1966, a U.S. Navy satellite observed magnetic disturbances on every pass over the poles. So scientists then found that horizontal electric currents do indeed travel along the auroral zone and then flow vertically along the Earth's field lines to form an aurora. And these currents were christened Birkeland currents in 1967. Today we remember Birkeland in other ways. Next slide. There's a crater on the moon named after him, as you see, Birkeland. And next slide. It's beside this crater, which is called the Van de Graaff crater. So here he is. And next slide. And just for reference, it's above the south pole of the moon, in that position right there. And next slide. And Norway remembers him. His face appears on a Norwegian banknote. And next slide. And even Google remembered him on his 146th birthday, which was last December. Any questions?
Thank you. Does anyone have any questions or any comments? Because clearly, Carmen, you put a ton of work into this, and this is exactly what I remember. And it wasn't 10 years ago. It can't be 10 years ago since you delivered it.
I think it was pretty close, but anyway.
So I can't imagine.
I have no excuse.
I've got a question.
Yes.
The magnetic field is going in on the North Pole and then coming out on the south Does that make
No, I
the,
think there are auroras on both the north and the south.
yeah, but is the aurora a bit different because one, the magnetic lines are going in and the other
Carmen, can you
going
come
out?
back to the mic?
My physics on that is not solid, but what I understand is because both poles have weaker magnetic fields, that the solar particles are able to get through that, just in the way that they were able on the sun's surface to escape through holes in the magnetic field there. So what they do is they enter through that weaker area in the magnetic fields on the Earth, and then that excites the gaseous particles there in our atmosphere.
But in the southern, south pole, they're going out, so does it make any difference?
It wouldn't, I would say it wouldn't matter, because they're going around the Earth basically and coming in
Okay.
to the poles.
They follow the magnetic.
Right, they follow the magnetic field lines and then basically go in. So, I
Yeah,
mean,
the
there's the
magnetic
orb.
pole. Yeah.
Because it's equally weak or, at the top and the bottom, north and south pole. Any other questions?
Awesome.
Okay, thank you.
Thank you, Carmen. So maybe just as maybe a round of applause here, who would like to hear Carmen again come in the future? No pressure, Carmen, but really, truly, you know how to do this, Carmen, really well. This is well, you are for sure.
Don't get home when we're happy.
Yeah, that's right. That's right. Okay, thank you, Carmen. Wonderful. All right, next up is Dave Chisholm and his son Robbie. And I have to say, and I might have said this at a previous meeting here, I had the pleasure of having my telescope set up beside Dave's telescope, and I'm sure he's going to mention in a minute here. Listening to his son Robbie ask 1,000 questions and just trying to be so involved with his dad. I remember that with my son, and you don't forget these things. So it was really wonderful. Robbie, you're really something special.
Okay, we have the next slide, please. There we go.
My dad, my mom, and I visited the North Frontenac Dark Sky Preserve on Saturday, July 5th, to attend their star party.
Next slide.
Please. So,
No, don't. Just let them move it, okay?
okay. This map shows the area is in one of the darkest sky zones in Ontario, which is right there.
Next slide.
It is 1.5 hours from Ottawa, including a Timmy stop in Perth. We found that the longitude and latitude coordinates work the best with the car GPS, and the street address didn't work properly for some reason.
Next one.
In the background is the outhouse.
Next slide. There we go.
Okay.
Yep.
In the background is the outhouse. It was very clean and well maintained. I don't know why we're mentioning this, but
I wrote it.
just off the picture to the right is a power pole with 8 outlets, and there are now large boulders to prevent people from driving up to the pad and cracking it.
Okay. So this is a picture of getting things set up. The lady in the background with the white top is Betty Hunter. She's the local councillor who was one of the driving forces to get the site established. She consulted with local astronomers on what their requirements would be. And in the back left, the fellow was setting up a complete video system which showed some really amazing results throughout the evening. It's great having power on site. Well, this is a great site. They had some unfortunate interference from the folks at Orange in the middle of July. In the background, you can see the local Orange helipad. In true Orange fashion, without consultation with the municipality of North Frontenac, they showed up and installed bright green landing lights that are visible from 5 kilometers on the helipad. This has significantly affected the darkness of the site. Earlier this week, in response to my email, Betty Hunter, the local councillor, said, "We are still working on a solution to the lighting at the site, and we'll let you know as soon as the solution is reached." A letter has been sent to Orange and various government representatives to come up with solutions, as this is very important to us. I'll let you know of any updates. As soon as I hear anything, I will get an update sent over the RASC distribution list. Next slide, please. Here's some useful links to the site. I don't have a proper camera set up yet. Hint, dear, for Christmas. The background picture is that of Saturn taken with my Canon PowerShot, that fuzzy dot in the middle there. I just basically put it up against the eyepiece of my Celestron Nexstar 5 scope. I took this picture and then did some color substitution to come up with the enhanced image in the lower right. I have brochures on my $25 tripod up there on the stage for the North Frontenac Dark Preserve site. Thank you.
Thank you, Robbie and Dave. Robbie, you're welcome to come up again and present, and even bring your dad as well. Okay, just before we go to break here, I wanted to say a couple things about some membership benefits. For new members that are here, or for folks that are here tonight, just seeing what it's all about. Membership brings a number of benefits. We have a traditional astronomy library just around the corner. We also have, which is really well stocked and well used. We also have a telescope loan library, which is also very well used right now. And we have an observatory as well that is available to members. So this is among many other benefits. If you have signed out, I mentioned this last month, but I wanted to mention again. If you have signed out a telescope or if you have your own telescope and you want some help with it, please come see myself or Gary, or even try to introduce yourself to anyone that appears to be a member. But you're welcome to. We'd love to help you and get you going. Gary and myself have been trading notes about maybe having a telescope clinic, a setup clinic. So, and we can make that happen if there is interest. As well, there's a number of with your membership, you get Sky News, you get a electronic version of the RASC Journal, the wonderful handbook that Gary mentioned earlier, and here are the membership rates. If you're a family, there's a great rate. Basically, it's in the middle there. It's for the first adult, it's $77. For the second adult, the charge will be $87 altogether. Okay, so two adults, and there's also a youth and student rate. Okay, so I hope it's something you consider. And for people who've been coming to this meeting for a while, I mean, I'd like maybe if you could consider membership as well. There's lots more things we can do, obviously, with more funding. That's it for now. We're going to take a, let's see how we're doing on time here. We'll take we'll come back at 9 o'clock sharp. We'll start at 9 o'clock. If you haven't picked up your raffle tickets yet, please pick one up. And there's quite a few prizes here, including a Burnham's Celestial Handbook. We're going to give it out to whoever wins we're going to give it out as a set, the three of them. So that's some nice prizes. All right, next up is Chuck O'Dale. On identifying impact creators. So please welcome Chuck O'Dale. Thank you.
Okay, that was the last bell. Okay, last month we had a lady, Bianca Doost from the University of Western Ontario. She gave us an excellent talk on craters. And tonight I'm going to answer the question I'm sure you all have in your minds. How do I identify an impact crater? Essentially, if I'm walking through the bush and I see an interesting rock, could this be an impact indicator? Well, after our little presentation here, I hope I can answer that question. Oops, wrong way. Let's try that one. There we go. As you can see from the map here, these are the documented craters on our continent. And there are a lot of blank spots. So there is a lot of craters yet to be discovered. And hopefully Eric and I next spring might discover one. But that's another story. So to give you a bit of data, these bolides, relative velocities from 12 kilometers a second up to about 85 kilometers a second will impact our outer atmosphere. And just looking at it, a large bolide that hits the upper atmosphere could impact the Earth in anywhere from a second to about 6 seconds from the time it just touches the top of our our atmosphere. So if we're here, you'll see a flash, the next thing you know, you don't exist, if the bolide hits that cosmic velocities. If it's small enough, it'll slow down and basically goes thud on the ground, hence we have a meteorite. And the terminal velocity from a meteorite is around 300 meters per second. So if you get bonked on the head, it's going to hurt. Woo, a little bit of feedback. So, how do we know we've discovered an impact crater? Well, the obvious thing is, well, let's look for something circular. Here's actually an example of Eric and I's exploration up in northern Quebec a few years ago. And we're standing right about there in that picture. It's our dream come true, and there is a circular object, and that is, in fact, an impact site. So is every circular object we see resulting from an impact? Well, let's find out. First of all, here's a couple of craters on the moon, Ritter and Sebin. And they are circular, but if you look closely, they are kind of hexagonal. Simon Hamner has an excellent article on our website about that. I won't get into it, but the physics on impact craters is a bit deeper than I thought at the beginning. And I just flashed up the Clearwater impact craters just north of Quebec, in northern Quebec, that is. They are a set of double craters, 290 million years old. And I put that up there to show you the relative size. If you ever get a chance to look at these two craters on the moon through your telescope, now just imagine you're on the moon looking back at the Earth, and the Clearwater craters will look the same size as those two, just to give you an indicator of how big these guys are. So, let's look at some circular structures to see if we can determine if they're impact or not. Well, there's two. Now, the one on the bottom left is actually square. That's the, I'm cheating here, they're both impact. It is square, it's the Behringer crater. It's only 50,000 years old. The Pingulate crater on the upper right is 1.4 million years old. Both sort of circular. So, yeah, that could be an impact. Let's look at these two objects. What do you think? One is, one isn't. The bottom left, or bottom right, is the Presqu'île impact crater. I have a good story to tell you about that very shortly. The one on the upper left is a carbonatite. It's basically a geological structure. And there are a few through southern Ontario that are circular and are caused by this geologic function. Here's a couple of structures up in Algonquin Park. They're almost identical. One is an impact, one isn't. Eric and I just explored both of them, and I broke my nose in one of them, climbing over a deep beaver dam. And the impact is the upper right. That's the Brent crater, 396 million years old. Look exactly the same, and they are pretty well the same size. So circular objects are not necessarily an indicator of a crater. And here are two circular objects. They're both in Lake Nipissing, and neither one is an impact crater. They are both carbonatites. Again, Simon Hamner gave me the geological lesson on it. They are, if you look on the eastern part of Lake Nipissing, you'll see these two structures, the Manitou Islands and the Callender Bay. Extremely circular. You would think, holy Mackinac, it has to be an impact, but nope, it's geological. So, circular objects, is it an indicator of an impact? Maybe. This is a mountain. Is it an impact? Well, we'll find out in a second. Okay, so we've gone through circular structures. I'm going to just show you some, I'm going to document some things that I've actually seen in my explorations in various craters. One is shattered bedrock. You have a circular object with shattered bedrock around, that could be an indicator of an impact. Here on the bottom right, you see the shattered bedrock just by the Pingulate crater up in the Arctic. Where I'm standing to take that picture of the shattered rock is right about there. And it's right just on the outside of the rim. And there are sheets of pristine bedrock around the crater, and as you get closer to the crater, you see the rocks do get shattered. It's quite phenomenal. A couple of other examples. One is Sudbury, the 1.8 billion year old crater. The shattered rock through a rock cut. A geologist up there pointed that out to me. And it is from the impact, this shattering effect. And the one on the right is from the Manicouagan crater. As Eric and I, again, explored this one, we are driving north up the highway towards it, and the rock cuts became solid to shattered in this diagram. So getting closer to the crater, you could see the rocks getting more and more pulverized from the impact of, 214 million years ago. So you can see we've been peppered quite nicely in the last 100 million years or so. So another indicator. Well, if you're lucky enough to find a meteorite, and if you're lucky enough to find a meteorite beside a circular structure, you're probably a good indicator that, yes, you found an impact. Around Beringer, they found meteorites, and in this case, this is the Whitecourt crater in Alberta. It's only 1,000 years old, and it was recent. It's been known for a long, long time. Hunters knew about it, but somebody discovered a meteorite right beside the lip of it, and through research, it has been indicated firmly as a impact site. The picture on the bottom right you see is from a LiDAR, a light probing system that you can actually see through trees, etc., and bush, and you can see the bare geological, the bare structure around the crater itself, and this stands out sharply as a circular object. And to explore it, this is Gillian and I in the bottom of it. That gives you an indicator of the relative size of the crater. It's about 30 meters deep and a very steep edge. And on the right image there, we did actually find meteorites around it. We were allowed to search outside the restricted area, and we did find a lot of meteorites. We also found a lot of wire and nails and so on. In the image on the right is, again, Gillian, and in the background is Roland from Calgary. So, Roland, if you're watching, how you doing, eh? And actually, very interesting. I'm going to go back. When you see a meteorite, normally what you see on the left image there is a meteorite, a rock that's gone through the atmosphere. At the cosmic velocities, it basically has a shock wave in front of it. And the shock wave heats up the atmosphere, which again melts the bolide. And through the speed, the melted parts just blow off. And what you get is this rough effect on a meteorite. Well, the meteorite in this image is the exact same rock, but a different shape. And why is it a different shape? Well, at Whitecourt, it was a very, very low impact velocity impact. Normally, cosmic velocities, you get a minimum of 12 kilometers a second on impact, and what you get is a very, very large explosion, the 1/2 mv squared formula. So basically, it's exponential with speed. The faster you go, the more energy you're going to dissipate. Well, this impact was at the point of cosmic velocities, but slowed down a bit, so that the bolide itself didn't completely vaporize. The solid part of the back of the bolide actually blew off, which gave us a lot of these shrapnel effects. And this is a piece of iron, meteorite, that's shaped exactly like a shrapnel piece. If you go through the War Museum, you'll see pieces of shrapnel from exploded munitions. It's exactly the same thing. It's kind of cool, and that's mine. Nobody can have it.
What, a falling star?
So, meteorites. The chances of finding meteorite, well, we know it's pretty slim, and chances of finding a meteorite around a circular object are probably very, very slim. So, another piece of geology we can look for is what's called breccia. And this is pulverized rock, bedrock, within a melted mixture from the impact. And what you get is these sharp shards, as you can see there, the geologic cameras for scale. And the sharp shards is basically the bedrock that was pulverized and then resettled into the impact melt. These are examples again of Sudbury, 1.8 billion year old crater. And again, the Manicouagan crater, the breccia around there, we found, it was wall-to-wall breccia at that crater, Manicouagan. It was just awesome. And I'll just show you. Let's see if I can show it. Right there, those islands there. When Eric and I were canoeing back, I have to picture this, a canoe full of rocks. It was calm when we started, but we got halfway across and the wind came up, and those waves were probably as high as this pulpit. And, Eric is a whitewater canoeist. He knows how to do it, so we hightailed it to this island, and we went up, basically the surf on the beach, I thought we were just going to go roly-poly in, but Eric steered us right in up to the beach. I was at the sharp end of the canoe. I stepped out. I was dry as no problem. The waves drove us about 5-10 feet up the beach. It was awesome. We were stuck there for a day, and we had rations for another 4 days. We could have starved for another 4 after that, but it was about 18, 20 hours before we got off it. That was kind of a cool evening. So, another way of finding that we have an impact crater is looking for impact melt. And this is a very good example. Again, this is Eric and I up in the Pingula crater. And Eric was fortunate enough to document this piece of impact melt. It's very unique and it's different than the rocks you'll find around normally. You can see the bubbles in it and so on. So it's essentially a melt that's hardened, and it's with the bubbles and that. So it is a different rock, but again, we have to have a specific analysis of it to ensure that, yes, in fact, it is impact melt. And the argon-argon dating of it will tell you exactly what the time scale for this crater was. And as I said, was at 1.4 million years ago. Was it? Yeah, 1.4 million years ago this crater happened. Circular object with impact melt around it. And as I went hiking around the crater, I found this large piece of impact melt. I put the caribou antler on it for scale. But this was, after several expeditions up there, they finally found this impact melt, which did confirm that it was impact related. And then they dated that to find the age. And on the right is a impact melt cliff at the Manicouagan crater. And the impact melt I found was about that spot, and the impact melt cliff is right at that dot. And it's interesting, where that indicator is actually a 10-meter piece of bedrock that was actually exploded from the crater ballistically straight up. And in the meantime, of course, with the energy dissipated, the crater melted a lake, it's almost 50 kilometers across, basically impact lava. And this rock went plop into it and slowly sank. And considering the age of the crater, the amount of erosion that's happened since, it's probably a kilometer plus, erosion has disappeared from the top of that cliff over the years, gives you an indicator of how fast this impact melt has crystallized. There are many papers on this, and it's an interesting read. But it's very unique to see an impact melt cliff with this 10-meter rock stuck in the middle of it. It was kind of cool. So anyway, another story. I was, again, exploring. I wanted to get close to this cliff. This is another impact melt cliff, just on the south side of Memory Bay there. And I was climbing this talus slope. You can see this pile of rocks just on the diagram on the left. And a talus slope is essentially all the rocks that fell off this cliff and then fell down on the bottom and just piled up over the years. So it's kind of unstable, and I've actually found out the hard way. As I was climbing this, I got to the point where the thing was so steep I was on hands and knees, and I was actually causing avalanches. And some of these rocks are, half a meter across, so I really didn't want to get my leg broken. So I stopped, and I took this picture. And I looked around and I found something that was really, really cool. And I'll tell you about it in a second. So, finally, what can we definitely find that will determine that we found an impact site? And the answer is shatter cones. A shatter cone is something that you can see with your naked eye, you can identify and confirm that, yes, in fact, it's an impact site. Now, this is an image of the shatter cone on Slate Island, and for scale, that's me right there. And Eric's in the canoe, taking the picture.
Largest shatter cone in the world.
Yeah, the largest one we've found so far in the world. It is big. So, when I looked down on that talus slope, that's the shatter cone I saw. So, wow. I went, yippee. Again, at Slate Island, the shatter cone that I just documented. And just this shatter cone here is in that area. And this one here, we paddle over in around that part of the island. So you can see the different types of rock and the different shatter cones. You see the striations there. And it was kind of cool to have it documented, the fact that, yay, we found shatter cones. Now, if you ever get up to Charlevoix, just north of Quebec City, you're traveling east on the north shore of the St. Lawrence River. You're coming to a big hill, and then you go down into the Charlevoix area. Stop at the top of the hill and just look. And you can see on the moon the Tycho crater. Well, this here is almost like the Tycho crater. There's the central peak, the annular plateau, and the valley around the crater itself. It just gives you the immense feeling of how big these guys really are. And essentially, the Charlevoix crater is only half the crater that you see there. The other half is half again out that way. So that's the central peak. Now, geologically speaking, we don't know where that half went. It's gone somewhere. And Charlevoix was, well, it's been there for 342 million years, so a lot's happened then. So, of course, the St. Lawrence River is a big fault area, so who knows? But if you find out, write a paper and get a Nobel Prize. So how was Charlevoix discovered? It was actually the shatter cone that I'm showing you right here. The road crew were going through making a rock cut and saw very interesting striations on the rock, called up a geologist, and he said, holy Mackinac, it's an impact crater. So if you're lucky enough to find a shatter cone like this on a rock cut, tell a geologist, or tell me first. Then we'll tell a geologist. So Presqu'île, I told you I was going to tell you a story about that. Here we are, Eric and I canoeing along. You can tell Eric and I did a lot of exploring together. So here we are canoeing around here, just enjoying life, looking for shatter cones or anything, and a big black cloud. Pretty well the same black cloud we saw this afternoon here in Ottawa. So we paddled like the dickens to one of these islands over here, and we got in there in the nick of time, and it was pouring down rain. So Eric and I are sitting there talking about life, the universe, and everything. And Eric says, look, Chuck, as a joke, he says, look, Chuck, a shatter cone. So anyway, after a while I got out and I said, what the heck with this? I'm going to get out and look around. So the first rock I picked up was a shatter cone.
It wasn't a joke.
Yeah, I know. Yes, it was. You didn't see them. So anyway, that shatter cone there I gave to Eric. And we went paddling up that area, up to about here, to find these shatter cones as well. These are embedded right in the bedrock. I have an example of a shatter cone here. I don't know if you show it on the TV. You can see the striations on it. And I'm going to leave this here as a door prize. This is a shatter cone that Eric and I did find at Presqu'île. So you can brag to your friends, I found a shatter cone from Presqu'île. So if you see something like that, you've discovered an impact crater. So let's get back to our original. Was this an impact site? Well, I wouldn't put it there if it wasn't, would I? It's the Beaverhead one down in Idaho, and how it was found was in situ shatter cones. So looking for a rock like that, that's the scale. You see that, tromping through the bush, you see something like that, tell me first, and then we can get on with it. Cool. This is the crater research circa 1950s. A few craters we found, and then within 20 years, it just expanded. So we're going to have more and more. But I mentioned Charlevoix. The picture I had there looking this way into the crater, you can see half the crater is missing. We have no idea where it is. And the mystery is that island there has absolutely no relationship to the crater. So there's a geological mystery. So I always like to finish our talks with comets. They're beautiful things. They fly by us all the time. It's a great thing they miss us. But if it doesn't, watch out. So, well, the lesson here is, well, don't lose any sleep, because it might not happen in a little while because, well, average, we have a large impact on this planet every 50 million years. The last big one was 65 million years ago. So we're kind of due. But as we mentioned earlier, tomorrow we're going to have a near miss. So duck. And I want to close with, I have a website that describes all my crater explorations. And bragging, there's over 120,000 hits on it. So, yeah. Thank you. And this is the door prize.
Any questions for Chuck while he's up here? Any questions or comments? You can always, oh my gosh, a couple of questions.
The images
Sure.
you had of the Sudbury crater.
Yep.
It seems to be very elongated and oval. Is that a geological distortion from glaciation, or?
That is an interesting question. See if I can go back there. Here we go. Yes. Right through the center of the crater, there's a major fault. And it's called the Pinocchian orogeny. This area here was moving this way and pretty well squished the crater. This is the hypothesis now. The fact that the whole area has been squished. Now, you know, when two continents collide, there's a heck of a lot of bending and crunching of rocks. So that's the theory right now. So that's the answer, I guess. You had one, sir?
Yeah, I'm not familiar with what causes the creation of a shatter cone. Can you
Okay, yeah, that's a good question. I forgot to mention that. Okay, when you get the impact, oh yeah, I'll repeat the question. What causes a shatter cone? Well, you look at the impact and you get this 1/2 MV squared explosion. It's a big explosion. And it vaporizes the impact area, vaporizes the bolide, and then pulverizes rock all the way out, and then it starts shattering. You saw the rocks that I showed that were the shattered rock cuts and so on. Well, between that two parts, what you get is the shock wave that goes through the bedrock very, very quickly shatters the rock in a cone effect. So the cones actually show where the impact was. And along those cones, it's a very high energy shattering effect. They have these striations, and they've only found them on nuclear explosions sites and impact sites. And we don't think there's been any nuclear explosions in the last 100 million years, so we can pretty well guarantee it's an impact. Yeah. Anything else? Yes, sir.
How do they determine how old the crater is?
Okay, with the impact melt, you get various dating effects. So when it melts like that, basically you reset the geologic clock. So you get argon, potassium argon, uranium lead dating. You can use them all, and they pretty well agree, plus or minus 1 million years. With that's only a small percentage over the billions of years we're looking at. So that's how we did. With the white quartz was interesting. They dated it with carbon-14. The impact layer buried some trees. They could date the trees that were buried. That's how they dated that one.
One other question.
Yep.
On the eastern side of Hudson's Bay, there's
Yes.
a perfectly semicircular thing. Has that been determined to be part of an impact structure?
We don't know. We're looking. That's all I can say. We don't know. Okay, thank you very. Oh, I'm sorry. Yes, sir.
How can one identify impact melt?
That's a good question. The one you saw here that Eric had, you can see the bubbles in it. Where are you? No, went too far.
Doesn't look like any of the other rocks around it.
Yeah, basically it's a bubbling effect. So essentially it melted and the bubbles went blub, blub, blub out of it. It's kind of a basic answer. You can see, whoops, where's mine? Did I show you? Yeah, here it is. You can see the bubble effects on the one I found as well. They're pretty well the same. But to be sure, you have to have it analyzed. You know, so when I say impact belt might be an indicator, well, a strange rock like that might be an indicator, but you have to have a professional look at it. So on. How are we doing? Okay, we'll cut her off. Okay. Thanks, guys.
Thank you, Chuck. Okay, next up is Eric with a outreach report.
This is my first time actually on a webcast. I just realized I've always been behind the camera. Today I'm in front of it. So everyone out there who's watching us, welcome. And if you have any questions about how to do webcasting, because I would like to encourage the other centers to do what we're doing so they can share their stories with us, just give me a call and I'll be glad to help you with the technical part. Chuck just summarized some of our explorations, and that information, that experience that I had with him, I use now for outreaches. So I go to schools, and on May 25th, I went to, if we could have the next slide, please. I went to my old high school, Philemon Wright High School in Gatineau, Quebec, and I started the talk by dedicating it to a former teacher who was killed in a plane accident in northern Quebec. He was on a canoe trip. Plane took off and went into a stall and killed him and the pilot. So I dedicated the outreach to him, Mike Robinson. Then I started with I was inspired by what one of the other presenters here did one time, talking about lasers and how you can't see lasers in space. So I started with a scene from Star Trek, and I asked the students, what's wrong with this movie, with what's going on here? And they all knew the sound didn't exist in space, but one of them got that because there's no medium in space, you can't actually see a laser unless if it hits you right in the eye. And then I went and introduced the, next slide please. I introduced them to the RASC and started talking about impact craters and asteroids, about the asteroid belt between Mars and Jupiter, and also the largest known asteroid in our solar system, Ceres, which has gotten me really excited because we're going to actually be exploring Ceres in the spring and seeing it up close for the first time with the Dawn spacecraft. So they were surprised to hear how many asteroids there were, and that those are worlds that we are about to explore that most people have never heard of before. And then we talked about how those asteroids make their way to Earth and create impact craters, including the one that hit in Russia a couple of years ago. And they asked me a lot of questions about what happens during an impact. I told them that we haven't actually seen a large impact in our recorded history, but that basically an impact is the transferring, like Chuck said, of an enormous amount of energy into an explosion that is similar to a nuclear explosion. It's not a nuclear process, obviously. It's a kinetic transfer of energy into the ground. But that even the smallest impacts are much larger than any bomb we can create. Like the Brent crater in Algonquin Park is the impact from that is 3 times larger than the largest hydrogen bomb ever exploded. So that gave them a sense of the energy involved in these explosions, and it's something that you can't actually witness, because if you see it, the shock will kill you. We had a Q&A at the end of the outreach, and for me, it was a real privilege to be able to, if we could go to another slide. By the way, this is not an impact crater. This is an example of an object that it's in northeastern Quebec that looks like an impact crater. And like Chuck had told you earlier, circular objects do not necessarily make impact craters. Next slide. And the Earth. And when we talk about impact craters and anything involving in science, what we're most concerned with, obviously, is the welfare of our planet, of the Earth and how it is a very unique place in the universe. That we've already discovered more than 1,000 exoplanets, and none of them display the characteristics of the Earth. We're hoping, and chances are it's likely that we will someday. And I ended my talk with the Q&A and inspired them to explore that once you leave high school, you don't abandon science. You bring science with you for the rest of your life. It's part of your life, and it's such an enriching part of your life, science. And to not think about things like, well, for example, I said, right now we believe that the speed of light is a fixed quantity. But now we're discovering that the speed of light has actually changed. And why not try to go faster than the speed of light? Physics tells us right now that we can't, but don't say that you cannot. You always have to try, because that's the way you do real science, by trying. So that was my talk, and like I said, I was very privileged to inspire these young minds. Thank you.
Okay, we're just about to go to the observer section, but before we do that, I'd like to, and for those people who are sharing their images and their sketches, if you could come up to the front here on the side here, we've got quite a few images. I want to see if we can do them all tonight. Really quickly here, I just wanted to make a couple of announcements about the next public star party we have coming up. It's 2 weeks from today. It's in our location at the just right beside the Diefenbacher, or the CARP branch of the Ottawa Public Library. If you go on our website, you'll see a link to our public star parties, and there's a map and directions and so forth. We post the go, no go on there, and if you're part of the our member list here, we also send out go, no goes through that, and some other related astronomy groups as well. We have rain dates as well, or dates in case there's clouds or cloudy skies on the 19th, backup dates are the 20th, and then the 26th, and then the 27th, okay? Likewise, in October, we have a star party as well scheduled with backup dates. You know, if all goes well, and because we usually have our best star parties, I think in October, we might try and squeeze in another one, okay? It's great, two of them, okay? So we'll see how that goes, because it's, mosquitoes are hopefully all gone by then, and the sun sets earlier, so it makes it for a really nice evening as well. Okay, so let's go to the observer reports. First up is Jim. Now we've got 28 images, so if the people could go fairly quickly here, Jim.
Is there a big buzzer that's going to ring? And
No, just me.
all right, go ahead. So the first image was taken on the 10th of August, the supermoon, the night that everybody was hiding in their houses, shaking their fists at the sky. No deep sky observing tonight. Well, I was out actually looking at a fabulously large full moon. I think a lot of people maybe don't appreciate how inspiring a target the moon is, even when it's a full moon, especially if you're doing imaging, because the detail that you can pick out in an image is pretty amazing. And you can especially pick out more so kind of the order of events of the creation of the craters, because the brighter the object, the younger the object, sort of thing. Next. And this is from 3 solar shots from the 24th, 2 weeks later. We had another unusually cloudless weekend. So this was taken with a Malincam SSI camera. It's a stack of, I believe it was top 20% of 500 frames. And it's with a Bader white light Herschel wedge with just an IR cut filter. And I believe I had a 2x Barlow on at the time through a 4-inch refractor. Next. This was again with the SSI, but now through a little 35mm H-alpha camera, a Lunt 35. I'm just playing with the color a little bit because the image is actually originally black and white. But good detail on the surface, some nice patterns around the filaments. It's pretty good day for observing. Next. And then this was a zoom up again with the Lunt 35 with a 2.5 Barlow on. And I thought that the detail in the prominence was pretty neat. Lots of loop structure, kind of give you an idea of the arches of the plasma moving over the magnetic field lines. So that's it. Thank you. Oh, there's one more? Okay. Some of you may remember back last winter and last fall, we had a workshop series trying to promote kind of getting people out and doing more hands-on type astronomy. So there was a break over the summer because people were busy, including myself. But we're going to get that going again, and the next one is actually scheduled, unfortunately, for the same night as the CARP Star Party, but if you can't make it to the CARP Star Party, maybe you can come to our workshop on the 19th. It'll be Intro to Binoculars and Binocular Observing, and it's being put on by Glenn LeDrew, so that should be exciting. If you're interested, just send me an email to RSVP, because the numbers are limited. All right, thank you. Thanks, Jim.
Yeah, who knows? It might be cloudy, Jim. So if anybody has any questions again for Jim, just he's sitting right up front here. Okay, next up is John Thompson, please.
Got a series of 4 deep sky images that were taken just a little over a week ago. I was down in the Adirondacks. We're blessed with very dark skies there, and my system was a Ioptron sky tracker mount and a Canon Rebel and a telephoto. Actually, I had 2 telephoto lenses. This one was taken with a 135 telephoto. It's about 4 minutes exposure altogether of 24 10-second exposures all stacked together, and I was actually quite pleased what could be obtained with just with a little telephoto lens. That's heavily cropped, and then I had to blow it up. But you can see a fair amount of spiral arms and detail there. I think the bloated stars are due to a chromatic aberration in infrared. I mean, it might need an infrared blocking filter to get rid of those. Next, the same lens, that's another 135 telephoto of North American Nebula. That was about a 2-minute exposure. And you can see the H-alpha emissions there, the reddish color. Next. Lagoon and the Trifid Nebulas, that was a bigger telephoto. This is a 300 millimeter telephoto that I had. And that was, I believe, just about a 30-second or 40-second exposure, again, tracked with the Ioptron. And one more. That, again, was the 300 millimeter telephoto. Now, this was a stack of 8 30-second subframes. And I was surprised, again, how much detail was able to be pulled out of that. So that's a total of 4 minutes exposure.
Can you point out the horse head in there, John, please?
Yep, right there. Oops, somebody's... oh. There's the Flame Nebula, the Horsehead Nebula, the M42, the Orion Nebula, of course, and then I believe that's called the Running Man Nebula, the one, yeah. So I've never seen the Horsehead, but I've been able to capture it on digital film. Okay.
Thank you, John. Next up is Gary.
And I'm back. It's supermoon time. This was the biggest, like I said, we had last month on August 10th. I was able to, this is also in the Kempville newspaper, I think CTV and CBC, I'm not sure. So yeah, just taken from a place in South Mountain and a beautiful moonrise. Who saw that moon on the 10th? Round of applause. Excellent. Very, very nice. Next slide, please. The spooky eyes. Venus on the left and Jupiter on the right. Spooky eyes in the morning. The next slide is just the morning after. So Venus really started moving on down. And you can see the god-awful times I get up in the morning. This is before work, not just for the image. Next slide. Comet Jacques. And these were 3 90-second exposures that I did with my Canon camera at 1600. It's the best I can go. And these are 2 stars in Cassiopeia. You would have 1, 2, 3, 4, and 5. Like I said, it's really moving now through through Cygnus, so just get the cameras out and you'll notice the beautiful green hue of it. Next slide, please. Okay, on the night of the beautiful conjunction of the Moon, Saturn, and Mars, I was watching TV with my wife and said, Deb, I better go outside and check if it's clear. Well, I can almost hear the angels as the sky parted over here. And after a few choice words, I said, come out here. Ran and got my camera, took some pictures. And this is the same kind of cloud that I took that lightning shot last year, but there's no lightning associated with it. So next slide, please. And the three of the Moon, Saturn, and Mars. And look what I caught here. Next slide, please. Just happened to have a meteor. Why not? And 20 minutes later, clouded right back up, zipper closed, thank you. So that was a great night. Next slide, please. And yeah, in the morning now, good old Orion is coming up here. The Orion Nebula is just hidden by pretty well in here. And the horse head is just about over here that John showed. So yeah, colder skies are coming, but enjoy these nice warm nights for now. And that should be it.
Gary, can we see your big shot that showed the meteor with the planets as well, please?
Yeah.
One more, yeah.
So this is actually an artifact of the lens. Even though I took off the filter, I had to kind of overexpose the Moon to get the two planets. So you can't really have everything.
Are you
But-
able to see that comet with the telescope?
Sorry?
Comet Jacques?
I saw it in binoculars, but in a telescope, yeah, definitely, because I had a few people over on one of the clear nights and definitely see it. But it wasn't that green in a telescope. Photography brings out color, as always. So if you photograph wide angle and you see a little green dot, just follow the path on the link to my website, and you'll definitely say, yeah, that's the comet. So yeah, why not? A little surprise. Really glad I had it. Okay, who's next? Thanks, folks.
Julia and Gordon Webster.
Can't do this without my assistant. Nice little lunar sketch. I'm not going to try to pronounce those because you can read them and I can't pronounce them. I really enjoy doing these lunar sketches, but I've got to get a chainsaw or something and attack the trees in the back because I only get about 55 minutes of the Moon in my backyard and it's gone. So this sketch is a little rough. It was cut short. Next, please. NGC 6826, that's the blinking nebula, or what is it? Oh, the blinking planetary, sorry. And if you haven't seen it before, when you look at it in a small telescope, all you see is a star, but when you look away, all of a sudden there's a nebula around it. And it's just the star overpowers the nebula when you're looking at it directly. I was actually able to pick up a little bright arc down here. There are actually two of them, but the other one's really faint, so I didn't get it. Next, please. And Comet Jacques. This was with my 120 refractor at 125. This is the day after Gary's photograph. Next, please. This sketch is with at the same time, but it's with a wider angle lens, or eyepiece rather, and it picked up Strove, 3053, right over here, which is like Albearo with the gold and the blue. The other thing that struck me as I was watching this over the course of about 55 minutes is, next slide please, is just how much the comet moved in under an hour. So it moved from roughly here to there in about an hour. This thing is really moving. The previous sketch was actually Astronomy Sketch of the Day on Monday past. And I think that's it. Thanks.
Thank you, Gordon. Up next is Joe. We are doing this tonight.
So my images were taken on my vacation in and around Hampton Beach, New Hampshire. This is, you might think it's the supermoon, but it's actually the super waning gibbous moon because I had clouds during the big days, but I still thought it was a very beautiful moon at the time, and the setting was good. The cost of this particular image was 28 mosquito bites. When you're going to a fishing dock and there's like fish around and seagulls, wear pants, not shorts. Next slide, please. I also got a picture of Comet Jacques. It's up here. This was taken on the August 20th, so a little earlier than Gary's and Gordon's images, but I caught it near the double cluster in Perseus as it was approaching Cassiopeia that night. Next. And on the August 23rd, I also caught Jupiter and Venus with the crescent moon. And this is over Place Bay in New Hampshire. Also a very early morning. Thank you. Thank you, Joe.
And that leaves you, Paul.
Thank you.
Well, hi, everybody. We've had some really nice conjunctions actually this summer so far, and even had some clear weather to observe them. So this is back on. Let me check my notes here. July the 5th, and you can see Moon and Mars just off to the upper side of it there, within less than a lunar diameter there. So a very clear night, and it was a nice pairing. Next one. Yeah, I got the eyes there too, Gary. Yeah. About 5 o'clock in the morning, it was very pretty. Before that time, they were sort of murked in the clouds there. They just cleared out in time, and I just really enjoyed the color variation from the horizon up to the blue there. But very nice pairing. I haven't seen a conjunction that close in quite a time there. They were within less than a lunar diameter from each other, and very prominent in the sky, very eye-like. So very nice sight. And the last one I have for you, Comet Jacques as well there. That was taken on the night, the same night that Gordon just showed you his sketches, his second sketch there. I think, in fact, that was probably within a half an hour of the time that he had stated on his slide there. So, yeah, just beside the comet itself in Cassiopeia, and the two emission nebula there, just up in Cephas. So, yeah, very nice night. And that was taken, that's August the 26th, so just about a week and a half ago. And that was taken also with a sky tracker, like John was talking about, and with just a 70 millimeter telephoto lens with the Canon 60DA and fairly heavily cropped there. But a really rich area for stars there. It's when you see the entire frame there, it's just a wash with stars from the Milky Way. So yeah, we were lucky to be able to see that. And if you get a chance, go out and check it out, because it's still fairly prominent. And yeah, it's an easy target through binoculars and a telescope. That's what I've got for you this month. Take care.
Hi, my name's Robert Dick. I have a telescope halfway between Ottawa and Kingston, and twice a year I have an open house. And unfortunately, activities for astronomy are governed by the moon, mosquitoes, and the length of night. And so it turns out the auspicious weekend is everybody has their activity on the same weekend, and so do I. So but if you like variety, you can go from one to the other if you like. The Rideau Ferry open house is on Friday, starting about 7 p.m. And that's did I put the weekends down? Yes, September 19th, and the Saturday, September 20th. On the Saturday night, about 5 p.m., we go into Perth and have dinner, and we come back after dark and then observe till the wee hours. So this is on the right is just a picture over the lake with the Milky Way there. And to get there, it's down Highway 15 through Smiths Falls, follow through Smiths Falls to a little hamlet called Lombardy. Then you make a right into a little road leading to Rideau Ferry, and it's down a cattle road called R8, and it's down there. If you want to get a hold of me to get a real map, then the email's at the top, rdick.robertdick.ca, or the telephone number at 283-7815, or you can just catch me outside and I'll give you this information. You can write it down a little more easily. Anyway, it's about an hour, 10 minutes south of Ottawa, so you got to judge your time. Most people end up leaving about 2 or 3 or 4 in the morning. There's 38 acres, so if you like camping, you can camp. There's an outhouse there. No running water at the observatory, but it's the observatory is located in a large field behind the cottage. So if you really need running water, we can use that. It's a 24-inch. You swap the secondary mirror. It's either F4 Newtonian or F16 Cassegrain. So if the seeing is really, really nice, the atmosphere is very steady, you can see fine detail. Then I put on the Cassegrain, and then we're looking at very fine detail. What the problem is that the lowest magnification is 500 power. And so Mars is huge, and you can easily see planetary nebula and so on. If the seeing's not so good, then we put in the Newtonian and you're at F4, about 2.5 meter focal length. And for that, you're looking at magnifications in the order of 100 up to about, depending on the lenses, up to about 1100. So it's a very versatile telescope, very large, and under fairly dark sight. And hopefully there won't be any mosquitoes around. If there are mosquitoes around, I'll have a little thermocell inside the dome. So if you want to escape the mosquitoes, you have to look through the telescope.
Second round.
Okay. So the problem with the one thing about the dinner, if you're interested in joining us for dinner, I have to know in advance, like on Friday, because the place in Perth we go to likes reservations, and I like to get them in as soon as possible, because it seems like social activities, weddings, birthdays, visitors, all seem to occur on the new moon weekend of whenever I'm having the open house. So we have to get the reservation in early. And if you wonder where it is, what I'll be doing is, because I'm not quite sure where I'm going to make the reservation, I'm going to be mounting it on the door of the observatory. So again, if you're interested in coming, contact me, and I'll fire off an email with an actual map. Okay, thank you very much.
Rick Wagner, can you come talk about the Falls and Stars event? And then we're going to close the meeting here, so you're not missing too much here.
I guess it must be my material. It was my picture of Rob's observatory and my talk that have shut us down. Fallen Stars, the Kingston and Belleville centers of the RASC get together every year and have been doing for about 13 years now to host a little star party down at the Vanderwater conservation area, Boy Scouts camping area. And when I say camping, I mean it's camping. So Friday, September 26th to Sunday the 28th this year. It's a small star party. If you're a beginner at star parties, it's kind of nice. There's usually 2 or 3 dozen people there. 2 large fields, quite open. There's a fair amount of trees around the fields, but that tends to block any sky glow. It's about maybe half an hour, 45 minutes north of Belleville. There's a website. If you search for Fallen Stars, F-A-L-L-N Stars, you'll find the site. It's on the Belleville RASC site. And it's a nice little star party. They have a swap table. We all love swap tables. A few talks, observing Friday night, Saturday night. There's a catered dinner Saturday night. And then every Sunday morning, everybody packs up and goes home. A little astrophotograph contest. What else? No running water. Well, there's a hand-pumped well that may be drinkable. We're not sure. Pit toilets. No electricity. But it's a good group of people, and it's a fun time, and just a nice, intimate little group for a fun star party. So go to the website. You have to mail in your registration. Oh, look at that. You have to mail in your registration, I think, by about the 15th of September. And it's $20 for the star party, $20 for the dinner. So if you have any questions, I'll be out in the lobby afterwards. Thanks.
Okay. All right, next slide, please. All right, we're just at the end of the meeting, and like I said earlier, if you want to watch this broadcast again or watch previous recordings of meetings, earlier meetings, you can go to this Ustream site. As I said earlier, just Google Ustream Ottawa RASC, and you'll see it. Eric will have this meeting posted probably in a day or two. Next slide. I mentioned earlier. Awesome. So as Eric just said, it'll be posted at the end of this broadcast, so very quickly. And I mentioned earlier about our astronomy library, just right around the corner. Check it out. Estelle has a pick of the month. We meet for drinks and fun times right after this meeting here at Kelsey's. Everyone is welcome. Actually, we didn't put the number in. It's 114 people joined in person tonight. That's great for a September meeting. Thanks to all the speakers. A great evening. Thank you, Eric Eunice and Bob Hillier, who stepped in for Chris Tarrant. So thanks, Bob, for making this happen. Next meeting, October 3rd, same place. I'm really excited about it. Now, it's interesting here. For whatever reason, we seem to have an Egyptian theme. Carmen talked about the fellow who is interested in Egypt. We had the Egyptologist in March. We had the lady who did the Monica Ferguson, who did the maps of the cosmos. There was an Egyptian theme there. And I'm going to be talking about how a very interesting theory on how the pyramids, the Great Pyramids in Giza, are, we think they were aligned so perfectly. The sides of them were aligned almost within a couple of arc minutes, okay? I think you're going to find the explanation very, very interesting here. So I've been thinking about doing this presentation for many months. It's been stewing in my head. I'm going to do it now. Simon, our intrepid planetary geologist, he went to Mars. So for those people who've been on his dispatches, you'll know what I'm talking about. I won't, but you'll have to wait. All I can say is Simon is Simon. Okay, and he's been up to lots of things that Simon is living the perfect retired life. That's what I want to be, exactly like that when I'm retired. Seems like so far away. That's it, folks. Okay, we're going to close the meeting, and then we're going to have right now run the door prizes. I think that's it.